Good morning all of you. In this video we will discuss about function transformer, what function transformation is and when to use function transformation and what happens after you apply function transformation, and at last we will do some coding part also. So without much delay, let's jump to our slides. So as you can see in our slides, let's pick one highlighter. Okay, first of all, you should know what frequency distribution is. Yes, frequency distribution means how much of your data has repeated in your distribution. Yes, and that we do it calculating frequency distribution. Yes, and there are normally three types of distribution. One is right skewed, second one is left skewed, third one is symmetrical. Yes, so let's discuss what this right skewed, left skewed are. Yeah, right skewed means, as you can see in our figure also, this is the right skewed data. Yeah, what does this right skewed means as you can see in the figure also, yes, this is your right skewed data, which is elongated to the origin of your distribution. Yes, as you can see here, the mode is the highest frequency and mean is greater than median, also mean is greater than mode. Yeah, and this type of distribution is right skewed distribution, and this is your left skewed. As you can see here, same as right skewed but in opposite direction. Yes, move away from its origin. This is your left skewed data. And symmetrical is this, where your mean, median, mode equals at the center. Yes, 50% data distributed to your left and 50% data distributed to your right, and this point is called your mean, median and mode. Yes, and normally as a statistician, you would always prefer to work in symmetrical data distribution. Yes, why? Because if your data is skewed, then it may form the outliers. Yes, so if it is the case, then this point may be your outliers, or sometime to your left skewed, this point may be your outlier. Yeah, but here none of the point is outlier, only some of the point is outlier, just like in the there and at the very edge of your distribution. But generally most of the statistical models is based on symmetrical distribution. Yes, and if your data distribution is skewed, then it forms the outliers, and we all know that outliers is not treated in a normal way in machine learning algorithms. Yeah, so I think you know what the skew data is and what your symmetrical data is. Yes, distribution is. So let's discuss what are the techniques that changes your skewed distribution to normal distribution. There are two techniques. One is function transformation, which we would discuss in this video, and next one is power transformation, which we will discuss in our next video. But yeah, let's study about function transformation. It is just a technique for changing your skewed distribution to normal. We all know that. Yes, so inside function transformation we have 3-4 types, or let's say these techniques where you can use the most. One is your log transformation. Yes, and second one is your square transformation. Yeah, third one is your square root transformation, and fourth one is your reciprocal transformation. Yeah, so these are some of the famous techniques inside function transformation that you use to change your skewed distribution to normal distribution. Yeah, and this arrow denotes that log transformation works better on right skewed data. This is your right skewed data, yes, and this is your left skewed data, and if you have left skewed data, then we use normally the square transformation. So this is all about the slide part, and let's go to our coding part. As you can see, we are currently in our Jupyter notebook. Yes, so these are some of the libraries that we would use while doing our coding part as a function transformer. Yeah, so let's run this, and I have taken one data set from Kaggle. This is our data set related to the scrap price. And what happens is, why to change your skewed data? Yes, we skewed distribution or abnormal distribution can hamper the models like regression models. Yeah, but to the decision tree, this skewed data may not hamper it. Yeah, but yeah, to the regression you have to change it. Yeah, so this is one data set that I have taken from the Kaggle. As you can see here, we have 205 rows and 26 columns. Sorry, but we would not take these 24 columns. We would take only one column, and that is let's first of all check for the correlation. Okay, below, checking for correlation. So why we are doing so? So that it could be easy for us to take the feature. Which feature? To take the feature data dot correlation with respect to price. Here price is our target variable. We would use, which is the one, which is this, engine size. Okay, engine size has the most frequency of correlation, so we would use that. Okay, now let's check for the skewness. Data dot engine size dot skew skewness. As you can see, 1.94. yeah, if it is greater than 0, positive skewed or right skewed. If it is less than 0, left skewed. And if it is equal to 0, then perfectly symmetrical. Yeah. And let's first of all plot the graph to check the KDE plot, to check the distribution. And for that we would use two techniques. One is by plotting KDE using C1 library, and by plotting QQplot from SciPy. And I have written some codes here. If you run this code, then yeah, this is the KDE plot. As you can see here also, this is your right skewed data. Yes, and what type of transformer works best on right skewed data? That is log transformation. Yeah, and QQplot, if your data points touches this red line most, then that distribution is regarded as symmetrical distribution. But here the data points are far away from the lines. Yes, somewhere the data points are on the line, but most of the time they are far from the red line. So this is not normally distributed. So as we know that engine size is a right skewed data, so we tend to use log transformation. So using log transformation, we can do it from two ways, either apply it using pandas or apply it using scikit-learn. Yes, so let's do using pandas. So I have applied here one code. Yes, data name of the feature dot apply. I have passed here the custom function, that is when I pass x, then I should receive np dot log x. Yes, why? Because we are just applying the log function and I am storing it into a new variable. So let's do that. Yeah, then after, when I use the same distribution, I will copy this. Yeah, copy, and I would paste it over here below, and this is data distribution after applying log transformation. This time column eng new, color same, not data engine, this is eng new. Okay, yeah, this is your data points. As you can see, somehow our distribution, look at the KDE plot, it used to be like this, right skewed, more elongated. This line is more elongated to the left part. Yes, but as you can see here, this KDE plot, it has elongated in both parts. Yes, and your distribution also looks like normal. Yeah, and to the QQ plot, most of the time the data points have touched the red line, not fully. Why? Because in real life you do not see the full normally distributed data. Yes, so this distribution is better than this distribution. Yes, it is more skewed than this one. This is also not fully normally distributed, but better than the previous one. So this is all about using pandas. So how we can do the same log transformation using scikit-learn. And one thing is, while developing the code or while developing the machine learning algorithms, we use scikit-learn. We prefer scikit-learn than pandas. Yes, so this is the preferred section while you are developing machine learning models. First of all, we import the function transformer from scikit-learn preprocessing module, and we are creating an object of it. And this is the important part. Either you can pass here in the form of lambda, or you can directly pass the function also, func. I have here used the func as np.log1p. Why I have used here log1p? This one is constant. Why? Because sometime your data distribution may have the 0 value also. Yes, so at that time your log function may not perform. So that is why, to eliminate that 0, I have used 1 as a constant. So that is why using numpy log1p. Yes, and I have fit my data engine to that function transformer. Yeah, and I have stored it into a new object. Let's copy this, and again plotting data distribution after applying log transformer, log log transformer. Yeah, so this is the one, the same plot. Yeah, here whether you use pandas to apply log transformer or you use scikit-learn, they both provide you the same output, but we prefer scikit-learn. Are you getting my points? Yeah. So as can be seen, this is the case of right skewed data. What happens if you have left skewed data? At that time we use square transform in place of this func. What we do is lam be the lambda x is to x power 2 for left skewed data. Yes, and for if you go with square root transformation, then there becomes 0.5. okay, for square root transformation. For reciprocal transformation, 1 divided by x. okay, for reciprocal transformation. Yeah, so these are some of the important techniques inside function transformation. Yes, so this much for you guys. In next video we will discuss about power transformation. Power transformation is also same as function transformation. Either you use function transformation or power transformation to change the distribution of your data from skewed to symmetrical. So thank you guys. If you like my content, please like and subscribe my channel. Thank you.